we are going to look into how we solve more complicated equations. Generally, fractions are considered more complicated, and it's a more difficult concept. So when we see fractions in an equation, we think that it is indeed more difficult, and it is. Imagine you are given to solve this equation. So the most difficult part here is x over 3. Now what if we have another equation which wouldn't involve fractions, like for example 20 minus x equals, let's say, 6x. How do we solve that one? So I would add x on both sides, because these ones are like terms, so I want to have both terms in one side. So I'd get 20 equals 7x. Now to get 1x, I would of course divide by 7 in both sides. And my final answer, divide by 7, and my final answer is x equals 20 over 7, which is the simplest possible. Now moving to the one on the left hand side, I'll do exactly the same steps. So I would need to have x in one side only so that I can collect like terms. Therefore, if I add x, I will of course want to deal with positive, so I will add x on both sides. So I'll get 20 equals x over 3 plus x. How do I deal with that right hand side? Imagine that you know that x over 3 is a third x. X is 1x. So you practically need to add a third plus 1. That's how many x's you have. If you put them in your calculator, you get 4 over 3. So the right hand side is 4 over 3x. Therefore, 20 equals 4 over 3x. Now, if you look in that equation, if I had 7x, I need to divide by 7 to obtain 1x. Therefore, I will need to divide by 4 over 3 to obtain 1x on both sides. So x is going to be 20 divided by 4 over 3. And that will be your final answer. Of course, you can put it in your calculator, or you can continue. How do I divide by a fraction? I multiply by the reciprocal of that function. So it's 60 over 4, which is 15, exactly what your calculator would give you. Probably the most difficult part was here to think that that's a third x plus 1x. A third plus 1x gives me 4 over 3x. Let's look at this equation. We can pause and think about it. There are two methods to solve it. First method, let me copy it again. See, we have 3 times that bracket is 27. So that bracket must be 9. It's the same as I divide by 3 both sides. So 2x plus 1 must be 9. Subtract 1 on both sides. 2x equals 8. Divide by 2. X equals 4. Now, to make sure that I'm correct, I can check by substituting 3 brackets, 2 times 4 plus 1. So I'm substituting it back. I get 3 times 8 plus 1. 3 times 9 is 27. So it's correct. My answer is correct. Method 2. If I didn't see that I can divide by 3, I can open the bracket. 6x plus 3 equals 27. Take away 3 on both sides. 6x equals 24. Divide by 6. So x equals 4. Same answer. I can check and I see that it verifies the equation. So it's a correct solution. How about solving this equation with fractions? See, unlike the previous example, I can't really think to divide this by 3. Yeah? So what I can do is that I can open the bracket. So I will have x over 2 equals 6x minus 33. bringing the x's on one side by subtracting, for example, 6x on both sides. Maybe it's not the easiest, but probably is the one that we'll see immediately. So we get x over 2 minus 6x equals negative 33. Now again, this could be a bit challenging, but if we think that that's a half x minus 6x, and if you put in your calculator a half minus 6 to see how many x's you have, you see that will give your calculator give you minus 11 over 2. So the left hand side is minus 11 over 2x equals minus 33. Imagine, remember you had half x minus 6x, so it gives you minus 11 over 2x. Same as in the previous model, I need to divide by minus 11 over 2 to be left with x. Imagine that x is something that if you times by minus 11 over 2, you end up to minus 33. So to go back and find x, you need to divide by minus 11 over 2. Therefore, your x will be minus 33 divided by minus 11 over 2. Again, you can do this with your calculator. If I'm to continue without a calculator, I will get a negative number divided by a negative number gives a positive number. So I have 33 divided by 11 over 2. I divide by a fraction by multiplying by the reciprocal of the fraction. So it's 66 over 11, which gives me 6. So x equals 6. Now if I go back and check in my equation, left hand side, this is an equal sign, that's a left hand side, that's a right hand side. So left hand side is 6 over 2, which is 3. Right hand side is 6 times 6 minus 33. 36 minus 33 is the same 3. So left hand side equals right hand side, so my solution is correct. And finally, let's look at this equation, who looks really, really complicated. But if you think that you'd replace fractions by other numbers, okay, first of all, x over 6 is a 6x. And x over 3 is a third x. So if I replace the fractions by other numbers and I get, for example, I pick randomly some numbers, 5 brackets 3x minus 1 equals 7 brackets 2x, for example, minus 1. How would I solve this one? I would open the brackets. 5 times 3, 15x. 5 times minus 1, minus 5, equals 7 times 2x, 14x, multiplying over the bracket. 7 times minus 1, minus 7. Here I do the same thing. 1 over 2 times 1 over 6 will give me 1 over 12. You can do it with a calculator. So we have 1 over 12x minus 1 over 3 times 1 gives you 1 over 2 equals 1 over 5 times 1 over 3 gives you 1 over 15x minus 1 over 5 times 1 is 1 over 5. And now we move to the right hand side equation. What can I do here next? I have x on both sides. These are like terms, so I need to bring them all in one side by subtracting 14x from this side. And then I will get x, 15x minus 14x is x minus 5 equals negative 7. I will do the same thing here. I have so many x's here and so many x's here. So I would subtract, really doesn't matter by which one, minus 1 over 15x minus 1 over 15x. So what do you have here? How many x's you'll have? You'll have 1 over 12 minus 1 over 15 x's. Same as here, you had 15 minus 14 x's. I can do this using my calculator. So I can see in my calculator that 1 over 12 minus 1 over 15 is 1 over 60. So I have 1 over 60x, remember they are x's, minus 1 over 2 equals, look from here, this one will disappear, I am left with minus 1 over 5. Sometimes when you add them, when you add the x's, you might end up with a negative, it doesn't really matter. Now I can do plus a half on both sides. So I will have 1 over 16x left on that side equals minus 1 over 5 plus 1 over 2. And now I'll put in my calculator minus 1 over 5 plus 1 over 2. And my calculator will give 3 over 10. So I'll have 1 over 16x equals 3 over 10. How do I get x? So remember, a simpler equation could be, for example, 7x equals 14. How do you get x? You divide by 7 both sides. Here I will need to divide by 1 over 16 both sides. So I get x equals 3 over 10 divided by 1 over 16. Which you can do without the calculator, but you can very easily put them into your calculator. 3 over 10 times 16 over 1. Yeah, which gives me 24 over 5 by calculator. And that's your answer to this question, which looks scary, but see, it's nothing different from a question as simple as that. Yeah, here we didn't finish, we'd add 5 to both sides and find the final answer.